Alex on stage. There you go.
Thank you. Yeah, so last year I have to give a huge amount of kudos to El Al for getting me out here. This year I managed to use British Airways. And it's interesting, El Al gave me a lot of hassle, probably because of what I managed to maybe do and not do. And then El Al, British Airways was like, oh, you're civilized, you're part English, you can come out with us. All right, so, hacking the humans. You first heard the psychology side of it, and then you had Chris give a fantastic talk about basically hacking the humans from a social engineering standpoint. Now we're just going to hack the humans. It's much easier. I'm done dealing with humanity, let's hack the humans themselves. So, today's topic, minions. Unfortunately, this is probably, I've got to make sure I stay inside the white line, otherwise that's going to get really crazy. We get to hack these kind of minions. Why are we doing this? Well, because if we look at how we're advancing ourselves, the logic is really we want to build better humans. We've tried endoskeletons, we've tried exoskeletons. You only have to look at the guys from the Borg and Wolverine. It didn't work out too well for those guys. Then you start taking a look at what is the construct of a human. We're 18% carbon, give or take a bit. I'm like, okay, can we use those carbon nanotubes? The answer obviously is probably yes. And then the question, the eternal question from Mother Nature, well, how hard can it be? Let's take a look at how nature hacks humans. We're hacked every day by the viruses that we actually get. We're hacked on a regular basis, basically through the RNA coding. If you take a human network and you take an actual network, you can actually have a lot of overlay. You take a look at the viruses that get into our systems. They access the cells. They use our bloodstream as the transport methodology to get around us. And then they communicate out, basically using an infected host to go, hey, I'm infected, move on to the next body. And then you have the contagious exfiltration. I sneeze, you get infected. And then we take a look at how Mother Nature does this. We take a look at the core genetic material. And remember this slide fairly well, because this is the genetic material from a research standpoint that is being used in the nanotech stuff that we're going to be talking about. We're not taking nice civilized stuff, we're taking Ebola. And we're smiling like, oh, we can make this civilized, and we can inject it back into the body with all sorts of carbon nanotubes. It'll be perfectly okay, we've managed to do this before. If we take a note out of Mother Nature, can't beat it, let's copy it. So how do we do this? And this is where we start talking about actually hacking the human. We've broken it down fairly well. We will define the nanotechnologies or the nano thing. It's much easier that way. We'll look at building them, encoding them, deploying them. We do have a panic button 3/4 of the way through this. Hang on, the mic's on the wall. Probably should have had a handheld knowing me. So let's have a look at how we define them. What the heck is nanotechnology? This is the fun stuff. This is where we take something that's a couple of atoms across. We take a look at something that is one of the strongest, one of the hardest, and then has some fantastically freakish thermal properties. Then we start taking a look and going, okay, this is a really cool stuff. That when you get at a molecular level, the standard laws of physics that we have today don't necessarily apply. We start walking around with the quantum side of the world. So we have these fantastic materials that we can do all sorts of interesting things with. This is a nice, useful one. It's like, oh, how small are these things? Bloody small. We can build with these things. We've been able to build with them since mid-90s, probably before that. We have 3 different methodologies of building. So the same thing that we do with computational technology, how do I hack a computer system? The same kind of construct. I have to take the building materials, the programming, the code, the payload, the infiltration, the exfiltration the same way. I have 3 different ways. I have the ability to basically use nucleic acid robots, I've got bacteria-based, and then I have the nanoscopic assemblers which are being built today. So the abilities for a nanotech architecture to build itself, self-replicating machines at a molecular level. And this is what it comes down to, the whole concept of manipulating atoms. Same things that we do with an assembly line, except as it says, on a slightly smaller scale. So where are we? This is where EPFL's lab released this in late 2016. We have gone to the stage where each one of those is a carbon nanotube architecture, We are teaching them. We're able to get to a stage where we can have them do alphabets, we can have them do simple mathematics. And then we take a look at the manufacturing. This is always a useful indicator as to where everything is and where everything used to be. 2010, 1500s per gram for nanotubes. You fast forward to 2016, we're down to $2 per gram. We're getting better, faster, and smarter at building this next generation of technology. Now let's look at encoding the darn things. So in other words, I have my material, how do I actually do something with it? Well, we have a couple of different ways of doing it. We've got 3 different ways we have up on here. GE Nanotechnologies, so a UK and US based operation. If you go out there and do a whole bunch of research, they will show some good stuff. You have DNA computing. The ability to move something through a DNA life cycle and encode it into nanotechnology. And then the engineering guys basically came up with a programming language where you start using code, the simple coding that we use today. You are programming this. We've got a couple of slides a little bit further on about this one. There's a hardware language, Verilog is a really, really good one. And then Cello will help you. So what you end up doing, you say, hey, I want to build this sequence, I want to have this sequence, I want to design this sequence, and you can build it in a language that most of us can encode and program in. What do I mean in English? Gonna have some fun with this one. This is the fun slide. How far back can I go on this? I can go back to here. So, on the left side, Cello design program. Simple design language that we can use today. You take that design coding, you basically encode it, you use a constraint file, you build gate assignments. This is simple mechanical engineering. This is electrical engineering 101. And then you take that and you turn it into a signal. No different than we do on a computer network. Except in this case, that signal is transmitted either through a laser or through near-field wireless style communications. So, we have our technology, we've built our technology, we've encoded the damn stuff. Now what the heck do? We deploy it. We're obviously hacking humans. First, this is how we deploy it. What is behind me on the screen up there is basically carbon nanotubes that have been built that have been given little tails. Take a propulsion system, apply a heat source, laser, close to the body, close to the skin, the thing starts swimming around the bloodstream. So now we've got a motor at a micronic level. And by the way, we're going to teach them not only how to understand English and math, we're also going to teach them how to recognize chemicals in the body. We being the research laboratories, we being everybody else. This isn't a we, me, we. Now, do we have a panic button? Yes, but we're not going to hit it. Why are we not going to hit it? Because there are some myths that need to be dispelled first. The whole concept of getting these into the body currently exists. I'm purely injecting into a test subject, human or otherwise. No, you can't drink tainted water. No, you can't breathe the air supply. And Honey, I Shrunk the Kids doesn't work, despite all of our best efforts. So, we being the greater we, the entire community who's working on this, has a long way to go. The mechanisms are in place. We have the nanotubes that can communicate from internal to external. We have them that can move around the bloodstream. We have them that can actually attach to cells. We have the communication system. What we're working on, and what is being worked on, and what's being researched by a lot of the teams in the laboratories, pretty much so across the globe, is what we can do in the next 10 to 15 years. What, as a security industry, we need to come together and do is go, hey, can we pause for a second? Put a picture of the big, scary, hairy, 6'3" guy with a green beard on the screen, and go, don't let him hack things. I let you, but I really don't want to get hacked too badly. So, let's hit the panic button. This is something that was cooked up in the lab. This is a hexametric ring. So, in geek terms, we have the keys, a receptor binding capability. In other words, a virus that gets into the system and goes, hi, I'd like to make friends with something. I have receptors which fit some of your blood cells. Let's make friends, and it does. We have the ability for the transport. Bird flu, in this case. Nice simple stuff, fairly nice to get into the body. Then we have our bypass tools. Those of us, as Chris pointed out, that maybe break into things on a regular basis, we need a bypass tool. We have the reporting tools. What the heck's it doing in my body? How does it do it? This tells me how it does it. We have the payload, the drugs. So in English, we have the ability to take bird flu, we put carbon nanotubes on it. We told the body, hey, this is a really cool thing. The body was like, I'll bring you in, let's make friends. We put a tracking device into it. We put a deployment technology into it. In a good world, in other words, in a laboratory at the moment, we can deploy this close to cancer cells. So in other words, somebody on the outside can target better cancer cells. That's in the good side. On the bad side, yeah, we can target red blood cells. But it takes an entire computer room full of technology to communicate with it. No. $100 worth of Arduino and communication systems. Game over. Now we can hack a human with an Arduino and a couple of extra bits of equipment. Okay, now we can panic. Everybody good so far? See, I'm not allowed to hack airplanes anymore, so we'll hack something else. Maybe they'll let me hack airplanes a bit more. So, if that wasn't bad enough, they decided to drop it into the agriculture environment as well. So the agriculture industry's gone, hey, this is really cool, we really want to do this. We're actually going to put it in the food supply, we're going to put it into food processing, so the darn food that only does it look like rubber, it'll taste like rubber as well. And by the way, those supplements you have, we'll put it in those things as well. This is what we will end up with. That isn't me. Alright, so what do we do about it? How do we solve this issue? Well, like Josh and some of the guys and my predecessors before me and everybody else who's in here, we need to communicate and collaborate better. We obviously need to start taking a look at the deceptive tech, so technologies that are outside the normal stack of equipment that we have that sits there with blinky lights and doesn't protect us. We need to take a look at addressing with organizations, and we need to educate them and get them to listen. Ruh-roh. I remember taking these slides out. Okay, so best case scenario. Awesome stuff. Targeted cures for cancers, breaking blood clots, food delivery, breaking up of kidney stones, parasite removals, and all the other good things. Downside? Yeah, targeted attacks. Those of you that work in the security industry, the skills that you have, that's about to go away because we now become nothing more than a walking USB stick. We weaponize it, we lose control of the darn thing. Technology gains an upper hand. It's not going to be a really good situation. I leave you with this though. This gathering that we have here has the power to do so much good. All of you are here because it's put on by Kenan and everybody else is here. I'm running and everybody else. Do some good. Get out. Communicate. Collaborate. This is the future that we are working with. Let's guide it in a slightly better way than we have done in the past, please. With that, thank you very much.